this product rule. Product means multiplication of two numbers. So here we are discussing about the variables. Variable is what? X is variable, t is variable, x is variable, t is variable, y is variable. So here we see that y is in terms of multiplication of two variables. So here I am writing x square into sin x. So x square is one variable, multiple with the sin x. So here multiplication symbol is not there. We must remember and understand that the relation between x square sin x is nothing but x square into sin x. We must apply the product rule. So product rule means what? So let us consider, we have considered this as u and this as v. So here we find the differentiation of y with respect to x. So here first we must write u as it is. We differentiate v with respect to x, plus we write v and differentiate the first function with respect to x. We can write either of the way. Instead of u into dv by dx plus v into du by dx, we can write it as this as first. We can write this as first, this as second. Both are same only. So here if we consider this one v dv by dx as v dash plus v into u dash. So u dash is nothing but we are differentiating u with respect to x. V dash is differentiation of v with respect to x. So here we have considered x square as u. U is x square, v is sin x. So what we do? We differentiate this one du by dx, differentiating x square with respect to x. So what we do? We use first formula x power n is n into x power n minus 1. N is 2 here. If we substitute there, we get 2 times x power 2 minus 1, 1. So 2 power 2 into x power minus 1, sorry, power 1 is nothing but 2x. Remember that x power is 1. Similarly, we differentiate v with respect to x. So here sin x, standard formula is that differentiation of sin x is cos x. So what we have? U is there, v is there. We differentiated u with respect to x, v with respect to x. We substitute in this formula. So here dy by dx is u. What is u? U is x square into dv by dx is cos x plus v is sin x into differentiation of u with respect to x is 2x. Remember, we cannot multiply this x with 2x. Why? Because the complete term sin x is the variable. So this one we write it in this format, x square into cos x. Instead of writing sin x into 2x, we write it as plus 2x into sin x. Remember, sin x is the single term. We should not consider sin as sin is multiple with the x. So what we do? We do some more problems related to the product. So I am considering t equal to x power 3 into tan x. So let us consider u equal to x power 3. We differentiate this one with respect to x, 3 times x square. Similarly, we consider v equal to tan x. We differentiate this one. Practice this trigonometric function formula. You must familiarize this formula. Differentiation of tan x is secant square x. So here this is u, this is v. So dy by dx we can write it as, I am not writing the formula because already formula is already written here. So this is product rule. So here I am substituting here u is nothing but x power 3 first term we write it as it is. Second term differentiation is secant square x multiply with this one secant square x plus v is tan x multiply with 3x square. Remember this one we can write it as x power 3 into secant square x plus 3x square into tan x. So we are discussing about the basics of differentiation. We can leave this one as it is, no need to take x square as common and simplify. For understanding we can stop it here. So we discuss some other terms using the product rule. Let us consider y is x power 2 into cosecant x. See, remember in between multiplication is there. We must remember the formula of x power n is n times x power n minus 1. Then differentiation of cosecant x. Cosecant x is minus cosecant x into cot x. So we substitute here. I am differentiating y with respect to x. This is u, this is v. First we write u as it is. We write u as it is. Differentiation of cosecant x. Differentiation of cosecant x is minus cosecant x into cot x. Plus we write the v as it is cosecant x. Then differentiation of x square is, if we substitute n equal to 2 here, we get 2 times x. So 2 times x. So this is nothing but, remember the product rule, y is u into v, dy by dx can be written as u into dv by dx plus v into du by dx. Okay, we are writing the product rule using x square and cosecant x. Why we cannot write the trigonometric function itself? We can write, but we can simplify the trigonometric functions. Like if you write cos x into, we write it as cosecant x. So we can apply the product rule, or else we can modify this one. We can write it this as cos x. We know that cosecant x can be written as 1 by sin x. We can write it as cot x. While writing the answer, we get the different answers, but both are same. So here remember, this is u, this is v. dy by dx. I am differentiating this one. First term we write it as it is cos x. Cosecant x differentiation is minus cosecant x into cot x plus second term we write it as it is cosecant x into cos x differentiation is minus sin x. We check the answer whether we get the same answer for this one. What is the differentiation of cot x? Differentiation of cot x is minus cosecant square x. If we get the same answer, the simplified format also correct. So we can leave it this one as it is. Better if we understand the simplifications. So here we do the simplification. Cos x into minus cosecant x can be written as minus 1 by sin x. Cot x is cos x by sin x plus cosecant x is 1 by sin x into minus sin x. So here cos we can multiply, we get cos square x dividing by sin x into sin x is sin square x, minus is there, so minus, here sin x get cancelled, minus 1. So we take minus common, we can write it as 1 plus cos by sin x whole square. So minus 1 plus cos by sin is cot x square. So 1 plus cot square x can be written as cosecant square x. So this is for understanding the multiplication of trigonometrics may be avoided because we can simplify the product of trigonometric function.